Today we're going to learn about some basic science concepts. So first of all, we're going to start off with qualitative observations versus quantitative observations. So, quantitative observations, those sort of deal with things such as the number of items in an experiment, or just like the amount of something that you have. It's something that can be measured. Whereas qualitative observations, they're usually things that can be observed in an experiment, like if something is red, or if it's green, or like if it's smelly. So if I were to do an experiment and I had, let's say, these dots, could you give me some quantitative observations? Yes?
There are 2 red dots.
Yes, that's correct. Okay, what about some qualitative ones? Yes?
There are multiple dots.
Some qualitative. An observation that can't be measured. With multiple dots, it's still a number. Like if I were to look at these dots and look at this yellow one, I might say that that dot looks very bright. With quantitative things, it's the number, whereas with qualitative, it's like the qualities that these dots exhibit. On to our next topic, we're going to be looking at independent versus dependent variables. So in science experiments, to be able to conduct a good science experiment, we have to have variables. Does anyone know what variables are? Yes?
They represent something you don't know.
Yes, that's definitely true. And if we look at independent variables, we see that those are things that you, as a scientist, change in the experiment. So if you change those independent variables, what do you think dependent variables are?
They change depending on how the independent variables change.
Yeah. So if I were doing a science experiment, say, like if I was watering a plant, and if I were to have an observation saying, if I water the plant more, then the plant grows taller, what do you think is the independent variable?
How much water do you give the plant?
Yes, and what do you think is the dependent variable?
How tall the plants are going to be?
That's correct, exactly. You see, the independent variables are exactly what they sound like. They're independent of each other. You decide how much of something you're going to give the plant or what you're going to do. Whereas dependent variables, they depend on the changes that you make with the independent variable. And also, we're going to look at today how we're going to convert units of measurement. So, as scientists, do you think that we use the customary units of measurement, or do you use metric?
Metric.
Yeah, why do you think that we use metric?
They're easier to convert.
That's definitely true. So, like if we want to convert from, say, meters to kilometers, like it's much easier. Because if we look at how it progresses, each time you multiply by 10, so it increases. If you wanted to, say, convert from meters to centimeters, yes?
Divide by 100?
Exactly, that's correct. So each time you either multiply by 10 multiple times or you divide by 10 multiple times. And we can go over this later. There's a chart for all the different prefixes that are used for these types of units. And now we're going to move on to learning about how to write a hypothesis. So have any of y'all written hypotheses before?
I'm sorry, what is a hypothesis?
Okay, so a hypothesis is something that you do at the beginning of an experiment. It's like a prediction. It's a very specific prediction that you need to be able to test. Like, for example, if I'm going back to the plant experiment, a hypothesis would be something like, if I water the plant more, the plant will grow taller. And it's pretty much a prediction of what you think will happen when your independent variables change. An important part of a hypothesis is the if and then the then. Like, if I do something to the independent variable, then something else in the experiment will occur. It's your own thoughts about what's going to happen in your own experiment. So does anyone want to try to create a hypothesis? Like something that's specific. You could do like the plant example, or you could do like if you eat something, like what would happen.
If I give the plant more nutrients, then it's going to be bigger.
Exactly, yeah, that's pretty good. And to help y'all with remembering this hypothesis, I've made up an academic cheer for you. So it goes like this. A hypothesis is a prediction, not just a general description. It's testable and specific. Then you know that it's terrific. So do you want to read that with me? A hypothesis is a prediction, not just a general description. If it's testable and specific, then you know that it's terrific.